Welcome you all to this course EC8701 Antennas and Microwave Engineering. The preamble to this course is like, what is a microwave? What are the applications of this microwave? Where you will find such applications and where you will find such devices in your life, in your real life activities, or the preamble. Prior to that, we will be seeing what is course outcomes and then syllabus. Okay, so the electromagnetic spectrum is the one which comprises of the electromagnetic waves, RF waves, which start from 0 hertz to terahertz and beyond. Okay, so in terms of wavelength, if you want to speak, we can start from the wavelength comparable to the size of the building to the atomic nuclei when it is for a gamma ray. We are more concerned about this microwaves. What is a microwave? So a microwave is a form of electromagnetic radiation with wavelengths from 300 megahertz to 300 gigahertz. It starts from 1 to 100 gigahertz. In most of the literature, you could see it starts from 3 gigahertz to 300 gigahertz. So the reason why we call it as microwave is not the one which relates to the wavelength, because often we confuse with the fact that micro means it is a meter to millimeter. It's not micrometer. The next thing is at microwaves. What is the importance of this microwaves? You are speaking so many things about this microwave. It starts from 300 megahertz to 300 gigahertz. Okay, so at microwaves, the dimensions are comparable to the device dimensions. Okay, that is pretty different from what we are used to. Okay, since our first year, you might have learned all these things in second and third year of your course, like EC1 and EC2, where you will be having lumped elements. Okay, so because of this microwave frequencies, which makes your wavelength comparable to the device dimensions, now we will be speaking more about distributed parameters than the lumped parameters. I hope you may be aware of what is lumped and distributed parameters. Lumped, the one or the discrete components. Okay, you might have learned in EC1 and EC2 of your course, and the distributed components are the one you have learned in your transmission lines and RF systems. Okay, why microwave? What is the need for this microwave? So wireless communications domain with which this microwave finds its application, because it supports higher bandwidth. Okay, if the bandwidth is higher, pretty definitely the higher data rate. Focused beam than radio waves. Radio waves are spread. For example, if I speak about how an FM is going to radiate its electromagnetic energy through the FM antenna, okay, it's like a broader transmission. In case, okay, it's not a confined transmission. It is it's more of like omnidirectional in nature. It's suitable for point-to-point communication, like the one that happens for the satellite communication. Okay, the narrowband satellite communication, it often happens with L band, S band, and C band. The same is the case with your DTH as well. So it requires small antennas. Okay, so larger the frequency, very lesser the dimension of the antenna. Okay, that also paved the path for evolution of the antennas. Okay, so that is pretty clear when you look at the size of mobile phones. Previously, it was in the shape of a brick. Now it is much reduced and slimmer in nature. It's all attributed to the evolution in the antennas, and again the communication. Okay, again depends upon these microwaves. What are the prerequisites for this course? The one is electromagnetic fields. The next comes the transmission lines and RF systems. The fundamentals of the antennas can be learned using this electromagnetic fields. The transmission lines and RF systems will help you understand what is lumped, distributed, what is impedance, what is attenuation, what is phase constant, all these things. Okay, having done with the electromagnetic fields with its fundamentals as EC1 and EC2, okay, you will be knowing much more about the application of such fundamentals of electromagnetic concepts in antennas and microwaves in the forthcoming classes. So what are the objectives of this course? The course aims to help students understand the basic principles in antenna and microwave system. That's being the very first objective. The next comes the radiation mechanisms. So let's consider an antenna. How it radiates. Why an antenna radiates? How it radiates. What are the parameters that we need to look into if we consider an antenna for an application? The next comes the design and the concepts of microwave components. Okay, having done with the antenna, the other microwave components, we do have so many microwave components like isolator, couplers, we call it as directional couplers, magic T, all these components to be used, okay, in a system, okay, for realizing any a microwave link. Okay, it could be an uplink or it will be a downlink. Okay, so it relates to either transmission and reception respectively. Okay, what are the outcomes? Okay, if you're done with this course, okay, on successful completion of this course, what the student will get or takeaways for a student? It's like you will be able to apply the basic principles and evaluate antenna parameters and link power budgets. Okay, I hope you will be knowing what is the power budget. Is power budget is the amount of power, okay, that is available actually at the transmitter and what is actually available at the receiver. So how the power budget is being calculated, and to apply the principles of antennas, okay, and evaluate its parameters, design and assess the performance of various antennas. So given an antenna, okay, so whether I can choose that particular antenna for this particular application, so or given some specification, okay, so I'll be able to design some antennas to suit that particular need. Okay, let it be a GSM or a Bluetooth or a mobile phone or any automotive antenna, whatever it may be. Okay. The next comes the objective 3 is the design a microwave system given the application specifications. So you'll be able to design a system, particularly the microwave system. Okay, so using the objectives, okay, whatever you have learned using this course will be enable you to design a microwave system. Okay, how can I relate this course to the current scenario? Okay, so when you step out of your home, if you are going to get connected, okay, that means you're opting to any of these wireless technologies. It could be a GSM or it is an ISM. A GSM often that relates to your mobile phone frequencies. So it stands for Global System for Mobile Communication. It operates at 1.8 to 1.9 gigahertz, and people are also exploring, okay, this 1.8 to 1.9, okay, for 5G as well. So we are more used to this 5G and 6G. Okay, the next, maybe in due course after, you'll be enjoying much of bandwidth, all because of this a 5G which operates at the millimeter waves. Okay, that is some 30 to 40 gigahertz. The next comes the 2.4 ISM band. Okay, ISM is a license free 2.4 gigahertz Bluetooth and Wi-Fi. So all these Wi-Fi facilities what we have in our campus is all because of this 2.4 gigahertz of frequency. Next comes the WiMAX. Okay, so the other application of this microwave range is microwave oven. Okay, Sukon, I hope you'll be knowing how a microwave oven cooks the food. Okay, it will have some microwave source within which, okay, it cooks the food. So you should be knowing by this time how a microwave oven is able to cook the food. Okay, so next is the application of this microwave in satellite communication. As it was discussed in one of our previous slides, the microwave antennas are much preferred when it comes to satellite communication. So because it provides a narrow beam, a point-to-point communication for which we will be dependent on this microwaves. Okay, what are all the components of this particular course? What are all the things that is covered under this course? The first thing being the first unit, the introduction of microwave system and antennas. We'll be dealing with what is a microwave frequency band, the physical concepts of radiation, near and far field regions, and some of the antenna parameters. Okay, the next is radiation mechanisms and design aspects. Okay, so how and why an antenna radiates. Okay, that will be the learning out of this unit 2, as well as some of these antennas like aperture antennas, reflector antennas, microstrip antennas, frequency independent design considerations associated with those antennas. Unit 3 comes with the antenna arrays. Having done with a single antenna, okay, we may find it useful the arrays. Okay, that is also discussed in unit 3. Next comes unit 4. It deals with passive and active microwave devices. Okay, so we'll be knowing the fundamentals of microwave, what is microwave, in unit 1, and we'll be learning about some of the microwave devices, because one of the objectives is you will be able to design a microwave system given the specifications, for which you should be knowing what is passive and active microwave devices. So some of the devices are directional couplers, power dividers, magic T, attenuator, resonator, impact diodes, Schottky diodes, and all these diodes comes under energy sources. For example, microwave sources. Okay, unit 5 deals with micro design principles. Okay, how to design a system. So you should be knowing what is impedance, what is impedance transformation, impedance matching, some of the filter concepts. Okay, so I'm going to design a system. That system will comprise of an amplifier, a low noise amplifier, a microwave amplifier, a mixer, an oscillator. So these are the things that will be covered in Unit 5. Okay. Next, coming to the textbook. Okay, so the textbook that is used for this particular course is this John D. Cross, Ronald J. Markaffa, and Ahmed's Antennas and Wave Propagation. And next, that covers the first 3 units. And in addition to whatever is being covered in Antennas and Wave Propagation by John D. Cross, okay, some components of these microwave-related concepts will also be learned in David Possard's microwave engineering book, which also covers Unit 4 and Unit 5. So these are the references. So by this time, you should be knowing the need for microwave, the wavelengths of this microwave, and you might have definitely gone through, or you might have Googled how a microwave oven works. So it will be having a microwave resonator or a microwave source within which, okay, there comes the concept of this, the dielectric value or dielectric concepts, where water is a dielectric material. Okay, so based on, again, this, whenever the water dielectric molecule, okay, is bombarded with microwaves, okay, there is some bipolar nature and all those things, all leads to cooking of the food. Okay, so we have learned about the importance of microwaves, okay, and its associated impact on the design of antennas. Okay, so how it is going to be used, how it is actually used in modern day communications. So these are the learnings of this session. So I'll be seeing you people in the very first class to speak much more about what is a microwave band. Okay, see you. Bye. Take care.